In this lesson, we'll be talking about characters, strings, and formatting. Now, Java gives us a primitive data type called char to represent a single character. Right? Characters in Java use the single quote. That's very different from strings that you might be familiar with that use double quotes. So let's look at a couple of declarations. So here, char is our data type. Letter is the identifier, and it's initialized to the character representing a capital A. In the second line here, numchar is initialized to the character representing 4. Note that this is not the number 4, it is the character 4. So as I said, strings use double quotes, whereas characters use single quotes, and they're very different things. Strings, in fact, are a sequence of characters. The string hello world in this case is made up of 11 characters, 5 for the hello, 5 for the world, and 1 for the space in the middle. Characters are stored as numerical values using encodings. An encoding that you might be familiar with is ASCII encoding. Unicode is another encoding. So for example, the character for 0 to the character for 9 are mapped to the numbers 48 through 57. Similarly, the character for the lowercase a to the lowercase z are mapped to the numbers 97 to 122. Now this allows us to do some interesting things. This allows us to use numerical operators such as auto increment on character variables. It also allows us to use relational operators like the compare operator on two character variables. Now there are all types of characters. For example, you could have a character that represents a backspace, and that's represented with a \b. There's a character that represents tabs or a new line character that is commonly used. You might get into some interesting situations when you want to use certain characters such as a double quote within a string. So this is interesting because the string itself is represented with double quotes. So in this case, you would use a / double quote to represent that character within a string. So here's an example. Here I'm printing the string, he said Java is fun, and in this case Java is fun is itself within quotes. We'll try that out example in a little bit. Now Java has this interesting duality where it provides you a primitive data type such as char, which is written in all lowercase. It's a primitive data type, but it also provides a class for that data type, such as in this case character. But this allows Java to provide you additional utility methods. In this case, the character class gives you methods to check if the character is a digit, is a letter or a digit, is a lower or uppercase. It also allows you to convert the character to upper or lower case. Okay, now let's try out some of these concepts in code. We'll fire up IntelliJ. Now here I have pre-populated some code. I've declared two characters, C1 and C2. They're initialized to capital A and 4 respectively. And then I'm printing them as is. And then I have said that the characters are internally stored as numerical values. So I've cast C2 to int to show you what the character 4 is mapped to in the encoding. Then I do arithmetic operation auto increment on it on C1 and print the value, and then we try one of our character methods to convert it. So let's see what happens. We'll run this. So let's look at what happened. So first of all, it printed A and 4 as is, and then you'll notice here that the encoding for the character 4 is 52. Recall that up here the 0 was 48, so 4 away from it is 52, and that's how we got that encoding. And then we did auto increment, which made C1 from capital A to capital B, which it printed. Then we converted to lowercase. Right. Lastly, here's an example where the string itself has a double quote embedded in it as a character. So this is the character quote, and that's how it prints. So now let's continue and talk about the string class, or the string data type, right? The string, as we had mentioned, is in fact a sequence of characters, right? It is a class just like that we use like scanner or system, right? And strings are declared as follows. String there's a capital S here because it's a class. It is not a primitive data type. Right? This is the identifier, message, and then again you specify a string with double quotes. Now strings provide us useful methods just like a character class did. It lets us check the length of a string, extract a character at a particular location. Now notice the locations in for Java start at the position 0 and not at the position 1. So character at 0 will give you the first character of the string. Concatenate allows us to concatenate two strings. You can convert a string completely to uppercase. You can convert completely to lowercase. You can trim white spaces from the front and from the end. So let's look at a piece of code to help us understand this better. Here I've declared a string that is initialized to hello world. We use the concatenate method by passing in toJane to concatenate toJane to hello world. So now new message becomes hello world toJane, but message still is hello world, right? And then we check the length of message. So since it's still hello world, this would be 11. We check the character at position 6 for hello world. So this will be 0, 1, 2, 3, 4, 5, and 6. So that's the capital W. That's right. Note that you can also concatenate two strings using the plus operator. And in this case, we have overloaded the meaning of the plus operator from adding two numbers to also concatenating two strings, right? And that's covered in a subsequent lesson where we talk about operator overloading, right? You may know about using the scanner class to read ints and doubles, where you would have used the method next int or next double to read an integer or a double from the keyboard. There are additional methods available to us that help us with reading strings. So there's something called next, the next line, that allow us to read the next word at the keyboard. So word being anything that is separated by some white space, or read the whole line till it sees the next new line from the keyboard as a string. Additional interesting string methods available to us allow us to compare two strings using equals, or allows us to compare ignoring case, allows us to check whether the string starts with a particular substring, or the string ends with a particular substring, or the string contains a particular substring, right? Further methods allow us to extract substrings from strings. So this one will extract the substring that starts at position 5 going all the way to the end. This one starts at position 5 and ends at position 7, gives us that string. Index of gives us the first occurrence of a character within a particular string. Let's try this out in code. So I've pre-typed some code here. It's reading a word, then reading a line, and then calling to uppercase length and substring. So let's run this and we'll analyze what it's doing. So it's waiting for input for the first word. So we'll type that in. Say hello there. What are you doing today? Okay. So it computed a few things. Let's see what happened. So first it read the first word. So even though I typed hello there, long sentence, the next only read the first word there. Okay. And then the cursor was left here, and then when I did next line, it read the rest of the line there, right? So that's why that behaved like that. The next thing we did is we took the first word and converted to uppercase. We checked the length of the second string, and then we got a substring from the second string, which was basically meant to get this what word, and it extracted that. We also have the ability to convert strings that represent numerical values such as 123 or 12.3 into the corresponding integer or double value, right? So in this case, we're using the integer class and the double class. Just like char had a corresponding character class, int has a corresponding integer and double has a corresponding double class, with very useful methods. In this case, parse int and parse double to take that string value and convert it into that numerical representation. Now you might be wondering what happens if you pass in a string that doesn't represent an integer. Suppose this is ABC and you pass it in. What happens? The answer is that you would get an error in the form of an exception, right? And there are ways to handle that, and we'll learn that in future lessons, how to handle exceptions. There are ways to test the input. Scanner provides methods of the form has next int or has next double to check the input at the keyboard before it's actually consumed. So let's look at this example where I've declared an integer, and I am checking whether what is the input available at the keyboard, is it an integer? If it's an integer, this method called returns true. If it is not, it returns false. And if it returns true, then I can actually consume the value, right? So let's try this out in code. So here I have some very similar code. I am using hasNextInt to test the input, whether it's an integer, and if it is, then I read it. If it is not, then I print it's not an integer. So let's do this. The good case would be if it's actually an integer and it reads it and stops. Now, if it is not an integer like an ABC, it will detect it. Notice it's not crashing. It is gracefully detecting the condition. Now we can. It could even be a double, and it would be detected appropriately. Our next topic is formatting output. So far we've been using print or println to output strings to screen. Now printf gives us much better control of output, right? So printf is of the form as follows. It primarily contains an argument called format, which is a string just like before, but now it can contain a number of specifiers. Specifiers are of the form % followed by a character that are embedded in the string, and they are replaced by other arguments that you provide. So this is best explained by an example. So let's look at it. So in this case, we have a printf command, right, which looks, like a normal string. It's saying hello something, followed today's temperature is something degrees, right? It's embedded with these specifiers that are replaced by additional arguments that are passed in, right? So in this case, the first one is replaced by the first argument, which is a name, and the second one will be replaced by temp, right? The character that is after the % represents the data type that it is. So S represents a string, D represents an integer. Other ones are F for decimals and C for characters, B and B for Booleans. So let's actually try this out in code. So here is the same exact code, and let's run it. So you'll notice what has happened is it's taken the string Jane and it is put it in right after hello where that specifier is, and it's taken the temperature and put it in the next location. The formatting can be made even more precise by using width and precision specifiers, right? So far you've seen percent followed by a character representing the type. Now here additionally we are introducing a number. The number represents the size of the field that will be printed. So let's take an example of %5d. Now d represents an integer already. So what this is saying that you now use a field of width 5 and print the integer within there right justify. If this number is negative, you print it in the width of 5 left justified, right? So if the number is 1, 2, 3 in this case, it would print 2 spaces followed by 1, 2, 3. In the -5 case, it'll print 1, 2, 3 followed by 2 spaces. This can be extended to decimal numbers and strings as well. So in this case, the 6.2f. So what's it saying is use a width of 6 and use exactly 2 digits after the decimal point, right? And here it's saying use a width of 12 and try to fit the string in that, and use more space if you need, but if the string fits in there, make it right justified, right? So let's try this out in code. This is the same example as before, right? And if you just run it, we would get the expected result. So now let's change it a little bit. Let's play with this. So I'm going to put brackets around here to show the left and the right ends of where the spacing is, right? So here, this is what it would look like. Now, if now we put in like 7 here, it's going to use 7, and it's going to put the 65 right justified. So let's look at that. Right. Now if I made that a -7, it's going to left justify it. Right. Now similarly, we could make this into a double. And then we could add some numbers after the decimal point. And now here we're saying, use a space that is 10. And I want exactly 2 digits after the decimal point. I have to change my specifier to an F because it is a decimal. Let's see what happens. So there, it's using exactly 2 digits after the decimal point. It has rounded in effect, and it has padded to the left. Right? Okay, so far in this lesson, we learned about characters, we learned about strings, and then we learned about formatting output very precisely. All right, thank you so much.